What is an LCD screen? Televisions used to be hot, heavy, power-hungry beasts that sat in the corner of your living room. Now, televisions are slim, use very little power, and are quite cheap. All this started with the widespread use of the LCD screen or the liquid crystal display. Today, not only is your television likely to be an LCD screen, but also your computer, your calculator, and your phone all have these liquid crystal displays. So that begs the question, what are these liquid crystal displays, and how can they make such great picture? In this video, you will learn the history of the LCD screen and how it came to be, how a liquid crystal display works scientifically, the pros and cons, why we use these screens, the power LCD screens have and social impact, and the future of screens moving forward. First, we will hear about the history of these displays.
LCD, or liquid crystal display, has a fascinating history. The story starts in 1888 when a chemist from Austria named Friedrich Reinitzer discovered liquid crystals in cholesterol samples he took from carrots. He published his findings in the Vienna Chemical Society Times, which prompted other exploration throughout the first decades of the 20th century. However, it wasn't until 1936 when Marconi Wireless patented their liquid crystal light valve that the potential of utilizing LCD's luminescent properties were tested. The electro-optical elements of LCD were then discovered in the early 60s when Richard Williams of the RCA Corporation began to generate light patterns in the form of stripes on an illuminated screen. More tests were done until 1968 when the first LCD display was created by John Janning. 1972 saw the first release of an LCD product in the mainstream market with the invention of the LCD wristwatch by the International Liquid Crystal Company. That year also saw the creation of the active matrix liquid crystal display panel, which was essential to the later creation of LCD screens that we see in televisions. And by 1977, the first LCD TV was produced, and the rest is history. By 2008, LCD TVs held over 50% of the market share and were the industry's top seller, making a fine transition from experiments on edible carrots to revenue in gold carrot.
Second, we learn about the science behind liquid crystal displays.
LCD technology is based on highly electrically sensitive materials called liquid crystals, which flow like a liquid but maintain a crystalline structure. The atoms sit in geometrical arrays but are still able to move around. The molecules respond to an electrical voltage, which changes their orientation and optical characteristics. An LCD display consists of thousands of pixels, or picture elements, which are addressed individually by a voltage. Each pixel is essentially composed of subpixels of red, blue, or green light that can be switched on or off very quickly to make the final moving color picture. Liquid crystals switch the pixels on and off electronically to rotate polarized light. At the back of an LCD screen, there is a bright light which shines out towards the viewer. The millions of pixels are in front of this. Each pixel has a polarizing glass filter behind it and in front of it at 90 degrees. A polarizing glass filter has a grid of lines arranged in parallel, which blocks out all the light waves except those vibrating in parallel to the bars, where they can enter through the bars between the gaps. This effectively dims the light. With two polarizing glass filters, the pixel normally looks dark. In between the filters, there is a small pneumatic liquid crystal. Liquid crystals can exist in different substates between solid and liquid. In the pneumatic phase, they are somewhat like liquid. Their molecules can move around and shuffle past one another, but they are all oriented towards the same direction. The pneumatic liquid crystal can be switched on or off by applying an electric field. Each pixel is controlled by a separate transistor that can switch it on or off multiple times per second. When it is switched on, it doesn't rotate the light, which is then blocked by the filters, darkening the pixel as you can see. When it is switched off, it rotates the light passing through it 90 degrees, allowing light to flow through the filters, brightening the pixel.
Next, we see the social impact and the pros and cons of LCD screens.
When you think about LCD technology, social impact is probably not the first thing that comes to mind. But this technology clearly has an impact on our day-to-day lives. For one, LCD screens are so much more portable than their CRT ancestors. Nowadays, I can fit an entire screen in my pocket. Everywhere you go, you see LCD screens. In cafeterias, in restaurants, in households, on computer screens, and of course on smartphones. And before LCD technology, none of this was remotely possible. LCD screens also look better, plain and simple. The brightness is higher, colors are more saturated, and the picture is sharper. Watching your favorite sports team or your favorite show on an LCD screen is a more visually enjoyable experience than it ever was before. And you can get a good LCD screen for pretty cheap too, often for less than a couple $100s. LCD technology also has a pretty strong impact on our environment. According to Energy Star, LCD screens use on average 50% less energy than CRT TVs once did. And they also give up far less heat, which in many households can lead to reduced air conditioning bills. Believe it or not, a big TV like this actually strains a viewer's eyes less than a CRT television used to do based on the way the picture is displayed. And finally, these TVs are not made with any lead. CRT TVs often had 6 to 8 pounds of lead, and if those ended up in landfills and ultimately in our water stream, that could lead to lead poisoning. LCD technology is not perfect though. As far as the screens go, they have some trouble reproducing black images, and the viewing angles can be a bit limited. There's also some concern that the manufacturing process releases a harmful chemical called nitrogen trifluoride. And this chemical is harmful to our upper atmosphere. However, there is still plenty of debate within the scientific community regarding how much of this chemical is released and especially just how harmful it may be. Now, the other argument is that because these screens have become so much more portable and widespread, there are so many of them, and collectively they use up an unbelievably high amount of energy. Of course, this isn't really the fault of any particular screen, but the technology as a whole does have that drawback.
Lastly, we look into the future screens moving forward.
A large majority of screens used today have LCD technology, but will it remain that way in the future? The new big technology that could change the way you view screens and make LCD TV obsolete is OLED, which stands for Organic Light Emitting Diodes. OLED offers a significant increase in picture quality where the screen can control the brightness of each individual pixel, whereas LCD relies on backlighting for the pixels. OLED has a greater color contrast, brighter colors, accurate dark and black colors, and a curved screen for better viewing. However, LCD has the advantage of controlling the new technological innovation of Ultra HD 4K TVs, which more than triples the amount of pixels on the previous HD standard of 1080p. LCD screens were the first to be able to offer stunning 4K displays months before OLED technology was able to reach 4K pixels. Additionally, LCD screens are significantly less expensive, averaging to be a fourth of the cost of OLED screens. Until OLED screens can be manufactured at a competing price, LCD screens will continue to dominate. To improve LCD screens to compete with the new technology of OLED, manufacturers are experimenting with new innovations to improve LCD picture quality, such as quantum dots, which could greatly improve the way the light passes through the color filters. 8K pixel TVs are already being developed to blow away 4K TVs, and others are experimenting with screens with no glare from the sun or other bright colors. There really is no limit on what manufacturers plan to do to improve how we view our screens on our TVs and our smartphones.
Thank you for watching our video.